I'm Karl Geoca, Senior Business Development Manager for WavePro.
And I'm Cory Clark, Applications Engineer for WavePro.
We're here today to talk about PTFE and WavePro's tunable dielectric. So Cory, what makes PTFE a good choice for antenna and RF lens designs?
Well, PTFE offers many electrical, mechanical, and environmental properties that make it attractive for use in a broad range of RF designs. It's a low-loss material, which improves performance. It has a high working temperature. It's weather and UV resistant, hydrophobic, and chemically inert. So, for some of the same reasons that it makes a great gasket, it also makes a great antenna.
What's unique about WavePro's approach to PTFE dielectrics?
With an increased requirement for bandwidth and speed, RF engineers are always looking for new technology and tools to enhance the performance of their products. Ceramic-filled PTFE is commonly available in lower decay values. However, Garlock's product breaks the mold, producing unrivaled decay values in the low to ultra-low loss domain. It's made to order in a range of dielectric constants from 2.5 to over 20 and can be produced in 3D shapes and extra thick panels as a pure dielectric substrate or a copper-clad laminate.
You mentioned made to order. How does WavePro's team work with their customers?
Well, Karl, we're scientists, material experts, and mechanical engineers engaging with RF, microwave, and millimeter wave customers to produce optimized dielectric material for their designs.
How would you say Garlock is positioned to make an impact in the antenna market?
With the formation of WavePro, Garlock leveraged over 135 years of material science and 50 years of PTFE expertise to develop a new material with tunable dielectric properties. As a well-established materials manufacturer, Garlock has the knowledge, tools, and capacity required to meet market needs of WavePro and serve emerging customers looking for an edge.
Well, that's very exciting. Thank you very much for your time and insight.